In this video lecture, I will be explaining bubble sort algorithm. So what is bubble sort algorithm? Bubble sort proceeds by scanning the list and exchanging the adjacent elements if they are out of order with respect to each other. And it compares each element with the adjacent element and swap them if they are not in order. That is, if we say array J will be compared with array J plus 1. So these are the adjacent elements, and if we say array J greater than array J plus 1, then they will be swapped. So after first pass, the largest element will be at its proper position in the array, that is n minus 1th position, n minus 1th position after the second pass, and the second largest element will be placed at its proper position, that is n minus 2 n minus 2th position. So similarly, after each pass, the next larger element will be moved to the end of the list and placed at their proper positions. Okay, so if there are n elements, then n minus 1 passes are required to sort the array, and the procedure is as follows. So for example, if I say after first pass, okay, so pass 1, what happens? The largest element will be at its proper position in the array, that is n minus 1th position. Okay, and then after the second pass, pass 2, the second largest. So here the first largest element will be at its proper place. Pass 2, the second largest element will be at its position, that means n minus 2th position. Okay, and similarly after each pass, the next larger element, so after pass 3, the third largest element will be at its position. So if we say there are n elements, then only n minus 1 passes are required to sort the array. Okay, so what happens? Pass 1 will compare array 0, okay, array 0 and array 1, because we are comparing adjacent elements. So array 0 and array 1 will be compared, and if array 0 greater than array 1, then what happens? Exchange them. Okay, so swap will happen. So we have to swap. Similarly, then next array 1 and array 2 will be compared, and if array 1 greater than array 2, what happens? Again exchange them. Okay, and then array 2 and array 3. So see, each time we are comparing the adjacent element. So first 0 with 1 will be compared, and then 1 with 2, and then 2 with 3. And if 0 and 1 are compared, if 0 greater than 1, then we need to swap them. If 1 and 2 are compared and 1 greater than 2, we need to swap. 2 and 3 are compared, and if 2 greater than array 3, then again we need to swap. Okay, so what happens? Here we can say compare array n minus 2 and array n minus 1, and again if n minus 2 greater than, if array n minus 2 greater than array n minus 1, then we need to exchange them. So what will be the result after the first pass? After the first pass, the result will be the largest element of an array will be at its place, that means n minus 1th position. Okay, so array n minus 1 will say it is sorted. And then in pass 2, what we do, again we'll start array 0 and array 1 will be compared, and then array and then if 0 greater than 1 we need to exchange them, and then array 1 and array 2 will be compared. If 1 greater than 2 we need to exchange them. So like this we have to, then we need to compare array n minus 3 and array n minus 2, and if this is greater than this, then we need to exchange them again. So what will be the result after second pass? The result will be the second largest element will be at its proper position, that means n minus 2th position. Okay, so see, after first pass the first largest element will come at its position, means at the last position, and after second pass the second largest element will come at its position, that means n minus 2th position. And then like this, after third pass the third largest element will come at its position, and then we say pass n minus 2, same thing, n minus 2, again array 0 and array 1 will be compared. If this is greater than this we need to exchange, and then array 1 and array 2 will be compared. If this is greater than this, it will be the elements will be exchanged. So what will be the result of this? The result will be array 2 to array n minus 2 are sorted. And then in pass n minus 1, what happens? Same thing, 0 with 1 will be compared, 1 with 2 will be compared, 2 with 3, like that, and then the result will be array 1, array 2 till array n minus 1 are sorted. Okay, so if I have total n elements, so how many passes are required? Total n minus 1 passes are required. Okay, so let's take one example, then it will be more clear. So for example, if these are the elements, okay, that we want to sort. Okay, so here the elements are 40, 20, 50, 60, 30 and 10, and we need to sort them. So in pass 1, what we do? So there are 1, 2, 3, 4, 5, 6 elements. So the first element will be stored at 0th index 0, and then 1, 2, 3, 4, 5. The last element index will be n minus 1. So that's how in array we store the element. So here 40 is the first element at 0th index is 0. 20 is the second element, 50 is the third, and then 60 is fourth element, and then next, and this is the last element. Okay, so in pass 1 what we do? So each time we compare array 0 with array 1, and then array 1 with array 2. So the adjacent elements are compared. Okay, so here first we'll compare 0 with 1. Okay, these two elements, and then if 0 greater than 1, then we need to swap. Okay, so definitely here see 40 greater than 20, so we are swapping. So now 20 will come here and 40 will come here. Okay, so after swap this will be my array. Now next, which element we are going to compare? Array 1 and array 2 will be compared. So array 1 and 2, if 1 is greater than 2, so that is not true, so we need not swap the elements, it will remain same. And then in the next pass 2 and 3 will be compared. So 2 and 3 will be compared. So if 2 greater than 3, then we need to swap it. So 2 is not greater than 3, so we will not swap. So next, which two elements will be compared? 3 and 4. So now 3 and 4 will compare. So 3 and 4, so this array 3 greater than array 4, that means we need to swap. So after swapping, this will be my array. See here 30 will come at position 3, and then the index 3, and then 60 will come here. So you can see here 30 has come and 60 has come here. Okay, now the next, which two elements will be compared? 4 and 5 will be compared. Okay, so now array 4 and array 5. So if array 4 greater than array 5, swap will happen. So definitely this is greater than this. So we will swap and then this will be my array. So now after end of the first pass, you can see the first largest element of an array. So here you can see 40, 20, 50, 60, 30 and 10. 60 is the largest element. So 60 has come at its position, that means n minus 1th position. Okay. So this is the array after first pass. Okay. So now second pass, what will happen? You can see here 60 has come at its position, means the first largest element. So now this is already sorted. Now in pass 2 again we'll compare 0 with 1. We'll start. Okay, so 0 and 1 will be compared. So 0 is greater, the element at 0 will be array 0 is greater than array 1. No, that is not true. So we'll not swap. Next 1 and 2 will be compared. So here also 1 is array 1 is not greater than array 2. So we'll not swap. Next 2 and 3 will be compared. So when we compare 2 and 3, you can see array 2 is greater than array 3. That means we need to swap, and after swapping, see, swap means 30 will come here and 50 will come here. So you can see 30 has come here and 50 has come here. Now the next 3 and 4 will be compared. So 3 and 4 will be compared. That means if array 3 is greater than array 4, definitely it is greater than this. So we need to swap, and after swap this will be my array. And see, each time here in pass 1 we compared till last, but in pass 2 the last element will not be compared. Why? Because it is already at its, the last element has already come at its position. So this 60 means 4 and 5 will not be compared in second pass. Okay, so then you can see at the end of the second pass, this 50, that means the second largest element also has come at its position. Okay, so this is the result after second pass. Now in third pass, what happens? The first and the second, after first and second pass, the first largest element, that is 60, and the second largest element, that is 50, is already sorted. Okay, so that means in pass 3 we need not compare these two elements. Okay, so now in pass 3 again 0 will start from 0, array 0 and array 1 will be compared. They are already sorted, because see, array 0 is not greater than array 1, so we will not swap. Next 1 and 2 will be compared. So 1 and 2 means array 1 is greater than array 2. Yes, so that means we need to swap. So this is the result after this. Now next 2 and 3 will be compared. So 2 and 3 means definitely array 2 is greater than array 3. So we need to swap. And at the end of third pass, you can see the third largest element has come at its position. Okay. So now in pass 4, already first, second and third elements, largest elements are already sorted. Okay, so pass 4, these three elements we need not compare. Okay. So here again we'll start from 0. Array 0 and array 1 will be compared. Array 0 is not greater than array 1, so we'll not swap. Then 1 and 2 will be compared. So 1 and 2, so array 1 is greater than array 2. We need to swap. So after swapping, this is the result. Okay, and see here, and since 40, 50 and 60 we need not compare. So this is the result after fourth pass. So now you can see the fourth largest element also has come at its position. And then we'll go to the next and the last pass, because if I have 6 elements, so n is the number of elements, so total n minus 1 means total 5 passes will be there. Okay, so now here this 30 also, after pass 4, 30 also is sorted. So now 0 and 1 will be compared. So 0 and 1, array 0 and array 1, array 0 is greater than array 1, so that means we'll swap. And you can see here after the fifth pass, this is also sorted, and then the entire array is sorted after fifth pass. So this is how bubble sort work.